Let's look at question 1 of the tutorial. You should have gotten the tutorials back from your teacher or in the midst of getting back. Okay, so the very first part on A, right, you are supposed to suggest explanation for the observed stereochemistry for the reaction based on the different reaction mechanism. We noticed that a lot of you wrote very lengthy answers. Yes, we know that the question began by asking you to suggest explanation, but that doesn't mean that you have to write long prose. Remember that in chemistry, it always helps a lot if you are able to support your answer with relevant mechanism, especially for H3, where you need to draw a lot of diagrams and sometimes it's really a lot easier if you could just use a diagram to explain and then you just annotate along the way. Yeah, so we will really advise students to do that instead of simply just write prose. Like for example, 1A is clearly SN2 because there is an inversion of stereochemistry over at this chiral center. Okay, but instead of writing a very long story like telling us that there's an inversion and therefore the configuration switch from R to S, etc. Right? Why not you just draw a mechanism? I mean, we really think that it's a lot easier. So, for example, in this case, you can simply just draw an oxide coming in from the rear. Okay, because this whole thing is very nicely put up for you. So once it approach from the rear, right, then all you need to do is just repeat the structure. Just repeat the particular structure. And then after that, you might be aware that this is being pushed down because it's a rear attack. And then your OET is now pointing up. Okay, and then you simply do a bond rotation. You simply do a bond rotation around here. Okay, then the structure will be equivalent, and then you realize that your cell group is now pointing into the plane. Yeah, so a very simple mechanism together with some annotation, I think it helps a lot. Okay, so no need to write very lengthy answers. Okay, the next one would be you notice this interesting reaction where the substrates is actually quite similar. If you look at the right hand side, okay, so the right hand side is simply like this, is similar. The only difference is that instead of a CH2 over here, right, I put a O. Okay, so how would that affect reactivity? Well, I mean, if you get the clue that I get 50% of one and I get 50% of the other, right, you might be thinking about a SN1 mechanism. Okay, but a lot of the scripts that we mark, right, simply what the students did simply they just break this bond. Okay, so they just break this bond, and then once they break the bond, they show us this particular carbocation. So like this, and then this is projecting out, this is projecting inwards, H, and then with a plus charge over here. Okay, but take note that for this particular carbocation, right, it's actually not very stabilized because it is directly bonded to this highly electronegative element, which is oxygen. Okay, so it's going to make the positively charged carbocationic center even more positive. Okay, then if you recall from our resonance drawing activities, I think it should be activity 1. Normally, we would want to draw a resonance structure like this. Okay, so this might be a better form of representation in your answers. Okay, so you should get this and then with a plus charge here. Okay, then from here, you should be able to illustrate to us that your methoxide, right, is able to approach from the top and bottom plane with near equal probability. Okay, and then of course you need to show the bond breaking towards the oxygen. Okay, so this might be a much better answers as compared to you simply just drawing a carbocation like this. Okay, so just take note of it. Look out for heteroatom, especially nitrogen and oxygen, because they are in the same period as carbon. So there is a very high chance that they will want to use the lone pairs of electrons to stabilize the center by forming a direct pi bond. Okay, so take note of this. The last one is very interesting. You realize that there is no inversion in stereochemistry. Okay, and some of the students, of course, very rightfully point out that there's likely to be a double SN2 lah. So second order nucleophilic substitution happened twice. Okay, yeah. So some students actually propose that okay, I have a lone pair here, and then I just whack, and then I kick out the BR, and then in the process I form a cyclic intermediate. Okay, that looks like this. Okay, then yep, and then after that the hydroxide anion will approach from the rear, and then the ring will open up. Okay, very much similar to mustard gas. Very good thought process. Okay, excellent. We don't have issue with this answer. The only little thing that we just we thought that okay, I mean it's not really your fault, but you might want to be aware that SH, okay, otherwise known as thiol, right, is actually significantly more acidic as compared to alcohols. So the pK is around that of around 10, 9 to 10. So hydroxide can actually deprotonate thiol. So this is known as thiol. So a slightly better answer will be deprotonation of thiol occur first before an internal nucleophilic substitution, and then followed by a ring opening by OH minus. All right, that's it for question one.